All right, today we're going to talk about our systems of quadratic equations. So you've done systems before, but we've done them usually with linear equations. So just as a quick review for linear systems, and then we're going to graph it. Remember y equals mx plus b. So remember, this is your y-intercept. That's where you begin. And then your slope is here. So from this point, from plus 1, you're going to go up 2 over 1, up 2 over 1, and then continue the pattern. I usually extend it in both directions, and then draw your line. And then here, remember you're going down 3 over 1, down 3 over 1, down 3 over 1, and then again, continue the pattern in both directions. And once you graph them, wherever these 2 points intersect, or these 2 lines, excuse me, whatever point they intersect at, that is your solution. So the solution for these 2 linear equations would be 1, 3, meaning your x's and your y's are going to be the same at that point. All right, now this is just a little reminder of slope linear equations and how to move on the graph. All right, so now let's get into it. So we have solved the system defined by graphing. So first what you're going to do is we're going to take our first equation and let's get some information from it. So we know right away that is our y-intercept for C. And once we get C, we can plot that there. Some other important points we're going to need to find is our vertex. And then for our vertex, what we're going to do is x equals negative b over 2a. And you're looking here, remember a is 1, b is negative 4, and c is positive 6. So we really don't need c for this part. We just need negative b and 2a. All right, so when you plug it in, you'll get x is 2. So that is your axis of symmetry, if you have to graph that, but we don't. And then now to find y, you need to substitute in your x's to your original equation. So when we get that, we get y equals 2. So our vertex is at 2, 2. Now from here, we can just go ahead and we can graph by doing your 1a, 3a, 5a. So I'm going to go, a is 1, so go over 1, up 1, over 1, up 3, over 1, it would be up 5, so what you would put there. And then you're going to reflect it to this side. All right, so that's this equation graphed right here. Now we're going to graph g of x equals 3. Well, that's the same as saying all your y's are going to equal 3, so it crosses the y-axis at 3. And then if you notice, this intersects at 2 places. So our solutions are 1, 3, and 3, 3. Now there's no x-intercepts because it doesn't cross the x-axis. So this is all we need right here is just to see where they cross each other, and then that's your solution. So now we're going to take the same thing, but we're going to solve it using an equation. So for here, we're taking these 2 equations and they just wrote it here for you. Excuse me. So g, they substituted this into here. So we've got this equals that. And then go ahead, remember to subtract 3. And then you're going to have x squared minus 4x plus 3 equals 0. Once you get it equal to 0, you can factor and get your x-intercepts. So once we know that your x's are going to be 3 and 1, then we can go ahead and we're going to substitute it here to this equation. And then we're going to take this x and substitute it here. So let me scooch that over for you guys. Here. For that equation. So then 2 other points, or the 2 points where they're going to intersect would be 3, 3 and 1, 3, which is the same as what we had over here when we graphed it. So, and then also too, it makes sense because we said that your y values were 3, so that makes sense that they're the same. So remember, you just substitute one equation into the other, and then once you got that, set it equal to 0. And then, like I said, these are your x-intercepts here, and then these are points. These are the solutions here. Okay, So I want you to try both ways. So you need to make sure you're graphing. So find important points for graphing. And then you're going to go ahead and you're going to solve this equation. Now, if you notice, they already substituted that into here. And they already made them equal. So they already did the substitution for you. So remember to set this equal to 0, solve this one, and solve for that one. And if you did it correctly, you should get the same answer for both since it's the same equations. All right, so now you're going to do this one. So again, you're going to substitute this value in here for g of x since they're both equal to the same, and then go ahead and solve. Now on this one, we have two quadratics. So this is the answer. This is what you should get at the end. That's the solution. So what we're going to do is we're first going to set them equal to each other. So I did this one here, and I wrote this one here. And then you're going to set it equal to 0. So when you do that, remember you're subtracting the x squared, subtracting the 3x, and subtracting the 14 to move it all over to this side. And then you're going to get 2x squared minus 8x minus 24 equals 0. Don't forget to factor out your GCF. And then everything else left over is in here. And to factor here, you're going to make it into x minus 6 and x plus 2. And then set all of them equal to 0. So if you divide both sides by 2, that cancels out. And then you're left with x minus 6 equals 0. And x plus 2 equals 0. And you'll get x equals 6 and x equals negative 2. So these should be your x-intercepts. So now that you know what your x's are, substitute x into either equation. In this case, I did this equation because it's a little bit easier because you don't have to worry about negatives and all that stuff. So I used the g of x, and then I substituted that in, and I got y equals 68 when x is 6. So that's this point. And then I substituted my other value of x into g of x. And when I got that, I got y equals 12. So when x is negative 2, y is 12. And that's this point. So now that you got both of those, if we were to graph these, they would intersect at those 2 points. Or they're both equal to each other, or equal at those 2 points. All right, so like I said, go ahead and finish that one. And then now we're going to talk about graphing system of inequalities. So for this one, what you're going to do is you're going to graph both of these, and I did both of these for you. Usually I do want to let you try the other, but it's just important to make sure you've got the right information. So first what we're going to do is we're going to put it into y equals mx plus b because it's linear. And then this one is a quadratic, so I made it equal. So I kind of switched it around, and notice I made it -1. I switched the spot +9. So with this is pretty easy to graph. You just start at +5, and then you go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and continue the pattern. Now for this one, it's a quadratic because it's x squared, so I know your c value is going to be your y-intercept. So in this case, I have 0, 9 up here, and then we're going to figure out what the rest is. So we're going to solve for your x-intercepts, and what I did was I factored out a -1, and then now I have a difference of squares. So once you set that, you're going to get -3 and 3 as your answers. So I've got -3 and 3 here. Those are your x-intercepts. And we can continue the pattern because we know that a is -1. So we're going to go 1a, 3a, 5a. And when you do that, you're going here, you go over 1, down 1, over 1, 1, 2, 3, over 1, 1, 2, 3, 4, 5. And then you continue the pattern. And then you go to this side and do the same thing. Okay? And then go ahead, this is going to be dashed or dotted because it is not equal to. And last, we need to test some points because it's an inequality, so we need to figure out where the solutions are. So for both points, I'm going to use 0, 0 because it's not on the line, on either line. So let's plug in 0 here. And if you were to make, 0 here. And so when you do that, you get 0 is greater than 5. Well, that's false. So since it's false, we're not going to shade here. We're going to shade on this side of the dashed line and make sure this line is dashed. Okay, now let's do the same test point, but we're going to use this inequality here. And so I plugged in 0, 0, and I got 0 is less than 9. Well, since that's true, we're going to shade everything inside the parabola. And the solution is wherever they intersect. So this little area here is the solution. All right, so now we're going to do the same thing here, and it's just 2 quadratics this time. So since it's 2 quadratics, I know right away that's my y-intercept for the pink one, and then a is -2. So when I have to graph that, it'll be 1a, 3a, 5a. And then now let's go ahead and find a vertex from here. Since it's standard, well, we've got x equals -b over 2a. So we've got 8 over -4, which equals -2. And now I know your x value is -2. Substitute that in here. And we get y equals 10. So my vertex is -2, 10. Up here. And then I'm going to graph it. So again, since my a is -2, I'm going to go 1a, 3a, 5a. So with -2, so I'm going to go over 1, down 2, over 1, down 6, over 1, down 10. All right, and then do the same thing to the other side. Oops, go off my line there. And this is going to be dashed. That's a horrible dash, but anyways, you get the idea. And then now let's do a test point, okay? So the test point I'm going to use is right here. I'm going to use -1, 0. You can use any point you want as long as it's not on the line. And it was pretty close to 0, 0, so I didn't want to use that one. But you can pick any one that you want as long as it's not on there. So when I substituted in -1 and 0, I ended up getting a true statement. So that means I'm going to shade inside the parabola for that one, and that's my blue. All right, and then now let's go ahead and I'm going to shade inside, sorry, I said the wrong one. Inside, and that was my pink. Right here, so that's that guy. Okay, now we're going to do the same thing, but with the blue. This is -3, and a is +2 this time. So when I graph it, I'm going to go up 2, up 6, up 10. And then now let's go ahead and find x equals -b over 2a. I substituted in my values and I got x equals -1. Now that I know that, substitute in -1 to your equation and you'll get y equals -5. So your vertex is -1, -5. And then now, like I said, I've got my vertex and I'm going to graph my a value. I'm going to plug it into 1a, 3a, 5a. So go over 1, up 2, over 1, up 5. And if we ran out of space, but it would be up 10 if we needed to do. And then reflect it on this side. And then continue the pattern. And again, this is going to be dashed also. All right, now let's do a test point. So I'm going to use the same test point because this is also inside the pink. So portion of the parabola, sorry, the blue, sorry. Wow. Okay, get my colors confused, I guess. So anyways, I'm looking here. That is inside, so I'm substituting that into here. And then I'm going to get 0 is greater than -5. Well, that's true. So since that's true, I'm going to color inside with blue. And the solution is wherever they overlap. And that's a solution for your inequalities. So same thing you've done before with systems of equations. We're just adding the extra step of the shading the two figures on that one. And that is systems of quadratic equations.